On this video, we are going to be proving the cosine law, which states cos A is equal to B square plus C square minus A square over 2BC. And also, side A, which is A square, equal to B square plus C square minus 2BC cos A. On this video, we are going to be proving the law of cosine, which is for the cos angle A and also for the side A. To prove this law, let's consider triangle ABC. Let's consider triangle ABC. With side A, B, and C. Opposite side B, let's call opposite side B the small b, opposite side A the small a, and opposite side C the small c. However, let's get a right angle triangle from triangle AB, so that we call it triangle ABD. Now length AD, let's call it E, and length DC, if this is E, length DC will be B minus E. Now, length BD is our altitude, let's call it H. Therefore, to find sine A using trig ratio, so sine A, which is from triangle ABD, sine A will be opposite A over hypotenuse A, over hypotenuse A, which is opposite A is H, over hypotenuse A is C. Therefore, sine A is H over C. Making H subject formula, our H will now become C sine A. Let's call this equation 1. Also, from side A, let's find cos A, which is also from triangle ABD, so that cos A, which is adjacent over hypotenuse, which is adjacent over hypotenuse. What's our adjacent A? Adjacent A is E, and hypotenuse A is C. That makes cos A to be E over C. Also, making E subject formula, we have E to be equal to C cos A. Let's call this equation 2. Now, from triangle BDC, let's find the hypotenuse A, which is side A. So side A, using Pythagoras theorem, will be A square equal to the square of this plus the square of this. And what's the square of this? Which is H square plus the square of the adjacent, which is B minus E square. Let's call this equation 3. But recall that from equation 1, h is equal to c sine A, and also from equation 2, E is equal to c cos A. So let's substitute equation 1 and equation 2 into equation 3. Into equation 3. And our equation 3 is a squared to be equal to h squared plus b minus e squared, where our h is what? C sine A. We'll have it as C sine A all squared plus B minus, what is our E? Our E is C cos A, which is C cos A all squared. Now the square of C sine A will give us C square sine square A. Now plus, let's expand this. We'll have it as B minus C cos A, and also B minus C cos A. Let's expand this. Expanding B minus C cos A, you'll have it as B minus C cos A, and also B minus C cos A. B times B is B squared. B times negative C cos A is negative BC cos A. Now, negative C cos A times B is negative BC cos A. And also, negative C cos A times negative C cos A will give us positive C square cos square A. So, negative BC cos A minus BC cos A will give us negative 2BC cos A. Now, positive C square cos square A, whereas we have B square first, which means if we expand B minus C cos A times B minus C cos A, we get B square minus 2BC cos A plus C square cos square A. So let's replace it on our equation here. Which means we'll have A square to be equal to C square sine square A plus B square minus 2BC cos A plus C square cos square A. Now collect like terms. Collecting like terms, which means we bring C square sine square A and C square cos square A, which is A square to be equal to C square sine square A plus C square cos square A. Now we also have B square minus 2BC cos A, which is positive B square minus 2BC cos A. Now let's factorize C square sine square A plus C square cos square A. What's common here is C square, so that when C square is divided by C square sine square A, we get sine square A plus also C square cos square A divided by C square, we have cos square A plus B square minus 2bc cos A, which is A squared. Now, if you recall that sine square A plus cos square A is equal to 1. So, let's replace sine square A plus cos square A to be 1. We'll have A square to be equal to C square multiplied by 1. Now, plus B square minus 2bc cos A. This can be rearranged as A square equal to B square plus C square minus 2bc cos A. Now, if you compare A square equal to B square plus C square minus 2bc cos A with cosine A, when we are looking for side A, which is A square equal to B square plus C square minus 2bc cos A, so it has been proven, which means we've proved that the square of side A is equal to B square plus C square minus 2bc cos A. So now, let's go further to prove cos A equal to B square plus C square minus A square over 2bc. Hello, viewers. Please, have you subscribed to Learn with Mr. Abdul yet? If you have not done so, kindly do so now before we continue. And if you've done that, stay tuned for more exciting and educating posts. If you get to subscribe to this channel, you'll get first-hand notification on any educative posts I will be placing on YouTube. Thank you as you subscribe to this page. Let's prove cos A to be equal to B square plus C square minus A square over 2bc. Now, from A square equal to B square plus C square minus 2bc cos A, let's make cos A subject formula, which means we'll move negative 2bc cos A to the other side of the equation. Then we'll also move A squared to the other side, which means negative 2bc cos A will move to the left-hand side. Now A squared will move to the right-hand side. Moving negative 2bc cos A to the other side is going to cross the equal sign. Then the negative 2bc cos A will become positive 2bc cos A. Now it will now be equal to B squared plus C squared. Now, A square will also move to the left-hand side, which means A square will cross the equal sign and it will now become negative A square. Since we are looking for only cos A, let's make cos A subject formula by dividing both sides by 2bc. So we'll have 2bc cos A over 2bc is equal to B square plus C square minus A square over 2bc. 2bc cancel 2bc. We are left with cos A to be equal to B square plus C square minus A square over 2bc. Now, the cosine formula says the cos angle A is equal to B square plus C square minus A square over 2bc. And hence, we have cos A to be equal to B square plus C square minus A square over 2bc. Hence, we have proved the cos A formula. The same method can also be used to prove cos B and cos C. You can also use the same method to prove cos B and cos C. I hope the video is educative. Please don't forget to hit the subscribe button and also don't forget to hit the like button so that this video can go viral for other people to also get to learn from it. Don't forget, hit the subscribe button and the like button. And also stay tuned for more videos.